I want to introduce Aaron Schmidt. Many of you probably already know him. He is our Director of Delivery, and with the Australia time difference, Aaron's going to do a little bit of narration on this recorded presentation for us.
All right, thanks, Ryan. Definitely thank you very much to Ray Boland and the EQL team. As everyone's kind of mentioned, it is nighttime in Australia currently. So they were very kind to offer to put together some recordings for us. We've got a series of those. Quick background on this project, which Ray will give some insight onto it in the first video. The EQL architecture is comprised of AUD integrated with both utility network and SAP HANA in the cloud. As Ray will explain, the SAP integration is still currently in progress. So we are currently implementing with support to the integration of Ellipse. So this is a two-phase approach. As I mentioned, there's 4 videos here that will be part of this. One is going to be Ray giving a quick introduction of EQL. He's then going to go into pole loading with 360-degree wind analysis that was configured for EQL specifically. Going to give some insight into their conductor analysis, and then he's got a closing video. In between each of the videos, we'll take a little bit of a pause to see if there's any questions. I do have Jeff Dennison from the SBS team that's going to be joining us. He'll be able to try and facilitate any of the questions and answers. If we're not able to get any of the answers, we'll route those through to the EQL team and get those back to you.
Firstly, I'd like to thank everybody for the opportunity to present at the PUG 2021 on behalf of Energy Queensland. To introduce myself, my name is Ray Balon. I'm the Design Support Manager. My role in the business will be the custodian of all the design tools that we implement in the near future. Christian Parry, he's been the Unified GIS functional lead, pretty much the key architect, designer that has actually put the AUD product that we're going to show today together. I apologise, he's unavailable for this presentation. Bit of a background on our team. We've got 170 prescriptive standard designers across 35 depots in Queensland, and we have 30 non-standard designers based in our major depots. To give you some indication of where we operate, Energy Queensland looks after the Queensland network. You can see there it's about 1.8 million kilometres squared, and we've got 178,000 kilometres of power line. This is a bit of a drawing of what we're introducing as part of the Unified GIS project. To give some background, about 3 years ago, we amalgamated 2 large entities in Queensland, 2 different standards, 2 different processes, 2 different systems. So we are going through the process of unifying all our systems. For this presentation, we're obviously implementing inlines, automatic utility design. We do have a integration into Esri, our GIS system, and we do have a one-way integration out of Ellipse for our materials and works orders. As you can see from the slide, at the same time, we're also introducing SBS's substation design suite, primary and secondary, all with an integrated Bolt Pro. 2022, phase 2 of the project is when we actually have integration into SAP, our asset and works management system, plus our Vault will be integrated into our enterprise content management system, which is OpenText. The project kicked off late 2019, went through the tender and evaluation process. We engaged SBS September 2020. And as you can see from the slide, we're about 3 weeks off go live, intending to go live on the 20th of September with our AUD product, and pretty soon after it will be going live with our substation design suite product as well. Next 12 months is really working with our SAP AWM team to implement that integration back into AUD. By July 2022 is their go live date. Just a bit of background to our 2 design streams, our prescriptive standard designers. They pretty much only do designs that meet our distribution design manual requirements. All the structures that they use, the pole tops, the poles, pretty much everything is a pre-approved construction type, and their role is to put it together in a building block type scenarios. Our second group are our non-standard designers. They're our engineers. They design from ground up. Pretty much all their overhead design is done in PLS CAD. Lastly, before we get into the system, we probably need to look at the challenges or the issues that we've had as part of this project, starting and going forward in the short time frame that we've had AUD on board. Within the business, we had 120,000 compatible units, so that's like pole tops, combinations that we've got in the system. Pretty much at go live, we were going to have two different construction manuals, a southeast construction manual and a north-south construction manual. That's not going to change. We need to have the system to ensure that we could design, but design in the two individual using the two individual construction manuals. I wanted a system that met our future needs, but more importantly, didn't want to limit the designers to be able to go across areas and do designs in other areas. Certainly wanted one template. I didn't want to have two templates and designers working in different templates depending on the area. And I suppose the other thing was really about managing change, and that was, we want to implement a system today that we can use in the future as the manual changed. I think the biggest concern we had is our source data. We've got two very separate and very different GIS systems within the two businesses now. It's all 2D. We've moved into a new Esri model, has Z values, so we're able to visualize the data, or will be able to visualize the data at some stage in Esri in 3D. A lot of unknowns, a lot of so source data is certainly going to be an issue going forward with the use of the Lines Design tool. I think it's important to add before we head into the actual demonstration of AUD. Firstly, let me apologise. All my technical people are pretty heavily involved in the project at the moment. We're 3 weeks from go live, so everybody's a bit time poor. I obviously drew the short straw, so for that I apologise to everybody. I'm sort of have some technical background, but not a lot. The other thing is we are that close to go live, but it is a bit time poor. So this presentation is probably not as polished as I would have liked it to be, but it certainly will give you some indications of what we've been doing with the AUD tool. Lastly, before we go, is really want to put a shout out to SBS. We've been with them with obviously the Lines Design and Substation Design tool. We're throwing some interesting things over the fence to say, hey, how do we do this? How do we do that? And in most cases, they've come back with some really good solutions. So it's been a really good relationship, and certainly one of the best companies I've worked for, particularly in the IT projects that I've been involved in the past.
All right, so that's the first video, just the introduction. The next one is the pole loading with 360-degree wind analysis. All right, ready for video 2 when you are.
With the help of SBS, we've implemented a pole load or tip load for our prescriptive standard designers with the assistance of SBS. As you can see, just going to lay out some conductor, setting my defaults, which is standard out of the box. I've got my span. We do have a creep or inelastic requirement on all new conductors, so I've got a rule to set that. And now I can do my perform pole loading, click the button, This pretty much does a 1 degree increments, 360 degrees around the pole. Wind on pole, wind on conductor, tension on conductor, the angle of conductor, and it pretty much gives us a tip load at the tip of the pole. So it gives us a limit state tip load and a direction, worst case scenario direction, and everyday or sustained load at the tip of the pole with a direction or worst case direction on that scenario. So we got the results in sort of 3 locations. Obviously we get a message or an alert to say the pole is overloaded in our analysis tab. We also have created this geographical picture of where or which directions the tip load has exceeded the capacity of the pole. So it's magnitude as well, so by how far it's actually exceeded that the capacity of the pole. And lastly, we have obviously on the pole itself our actual values of worst case scenarios. Also part of pole loading, we do have stay calculations. Just putting a ground stay on the overloaded pole. One of the things I've found, part of the valuation of the pole, we do have setting depths of the pole because this is prescriptive standards. This particular pole and soil type is not acceptable, so I need to go in and obviously change my foundation type to stabilize backfill so I can actually get a valid sinking depth. And I can do my check my stay to make sure that the stay height and is correct. So I'm adjusting my stay height if I can find it. I'll get it soon. So yeah, I'll put the stay height at a value of 10 meters and my lead length, which is from the pole to the anchor point at its same, which is our preferred 45-degree angle. And once I've done that, I can do my pole loading again on the pole and stay by selecting the pole. You can see that I've actually got an error here, that my stay tension is too great for that size stay, so I need to go in and change my stay size to a bigger stay, and then I can rerun my calculations to check that it is the stay tension is okay in that space. It's all come up good. Obviously we've got orientation. We still don't have orientation of stays in the tool yet at this point in time. Now the part of the stay calculations is pole bending moment. I'll just actually produce an error. I'm going to lower that stay height down to 5 meters, halfway down the pole, which will obviously give me an issue with bending moment of the pole. We only do single type stays in a lot of scenarios in Australia. So if I do the calculations now on the pole, you can see that it's actually failed bending moment. So our utilization is that pole and that capacity of pole has exceeded. Part of the system, we also can put in aerial stays. I'm just going to put a aerial stay on this pole. We can see it's overloaded, and I'm going to put a stay on. Process for doing this is simply placing a pole, and then I attach my stay between the 2 points, and put my aerial stay. As soon as you put a stay on, our pole loading just basically goes back to a message so that the calculations can run. Our engineering group has asked to make sure that whenever we put a stay on it, it is actually on the ground. Just so that a designer has to make a conscious decision and actually look at the design manual to determine the best point or the proper point for that stay. If I look at here, I've got my stay height. That's my takeoff pole, height 1. I'll set it at 9 meters. Height 2 is actually the height on the bollard. I just chucked a pole in. I certainly haven't put a proper bollard pole in that. Then if we select it all and do our pole calculations, actually it does the calculation, but it also transfers the tip load from the main pole to the bollard pole. And as you can see from the scenario is my stay is okay, my aerial stay is okay, but I now have a failed bollard pole. I've either obviously got to upgrade that or put a ground stay on on it. Jumping back to my original ground stay, we've obviously gone through. We have a ground stay and we've got an aerial stay, but we also have a sidewalk stay which has a strut halfway down the pole, which we all can do calculations on bending moment at the attachment point of the stay as well as the attachment point of the strut.
All right, so that was the second video. I know there was a question out there. The question is, that is a custom feature they developed in terms of the loading the graph, or is that out of the box feature?
It was a custom configuration. It's not a customization that's out there. To do that type of configuration is in the core product. It's just very advanced configuration.
The next video is conductor analysis.
We've also added to meet our design standards some conductor analysis. I'll start this by laying out a single span of moon conductor. This analysis is really about a few calculations that we have contained within our design manuals. Firstly, adjust my creep in elastic, and you'll notice I've got some ground clearances for this span of moon. Before I do my conductor analysis, I will go in and up the CBL of that to increase the tension of the conductor so that I don't have ground clearance issues. Do that by changing my CBL, and I can do my conductor analysis. Adjusting the CBL has fixed my clearance issue. However, I now have exceeded the maximum tension allowed for this conductor under our design manual. We have also included some mid-span separation calculations. If we can just imagine this is a line, we've got adequate clearances, going to reduce the CBL, reduce the tension. Obviously, I have got ground clearance issues here, but for the sake of the exercise, let's assume it's all okay. If I now do my conductor analysis, checking on mid-span at that tension, which is a pretty low tension at 6%, I now have a mid-span separation issue under our design standards. If I now go and increase the tension, or increase the CBL, I should say, I can clear my mid-span separation issue and also my ground clearance issue. This conductor is now passed. I'm not exceeding any maximum tension issues. I'm right to go. So that covers off on inter-circuit clearances. Now we're looking at the vertical clearances between two separate conductors. I've got my 11 kV. I'm just putting some three-phase low voltage mean conductor underneath the 11 kV conductor. And now I've got two circuits of different voltages, and I need to do some checks to ensure that we have appropriate vertical clearances. Firstly, as always, I need to adjust my, it's a new conductor, so adjust my creep or inelastic. And you see I've still got some clearance issues on my low voltage conductor. We look at the 3D view, it's pretty obvious when just by looking at it, my low voltage is a bit low, so I'm going to go and adjust my CBL on that conductor to make sure I've got adequate ground clearance. I just sped the video up because I didn't get it right the first time. And to force a mid-span vertical clearance error, I'll just go and adjust the CBL of the top conductor, so to ensure that conductors get closer, and as you can see, now I'm getting a vertical mid-span clearance issue. The last function that we have in the conductor analysis button is uplift. I've laid out these 220 meters spans of Moon, my favorite conductor. It's probably the only one I know. What pretty much we're doing is looking at just to produce a uplift issue. I'm putting some height Z values, ground line values on the outer poles, just to give us uplift issue on the center pole. So I've raised the one pole up 10 meters and the last pole up 15 meters. I'll switch to 3D just so you can see the visual that we do definitely have an uplift issue on that center pole. If I now run conductor analysis, you can see that it comes up with the value of uplift, because we have some scenarios where a minimal amount of uplift is allowed. I suppose one of the things that's important, and we've done a lot of work on, is because we do have some calculations, or a lot of calculations starting to come in AUD, we've had to ensure that when we're putting our network together is that we do have accurate measurements, so all our models and wires, etc., all have all the appropriate information and geometry so that we can actually do the calculations effectively.
Okay, great. Well, we thank everyone for joining today. We'll see you on Thursday.